What's up to you all awesome Mindsetters, grade 12 Mindsetters? It is yet another great Thursday where we are about to learn more and learn extra right here on Learn Extra. My name is AB, also known as Abram in full. Otherwise, we're here to learn more because it is all about geography. I'm joined by an awesome teacher. Michelle, how are you?
Fine, thanks. How are you?
I'm doing great. How are you feeling about this lesson?
I'm feeling excited, I'm feeling rejuvenated, I'm feeling really happy just to help some learners out there.
That's me already. Even the Mindsetters on the page, they're all pumped up and ready to learn more. What are we doing?
Well, we're going to be looking at mid-latitude cyclones today, so I hope that they are ready for a fairly complicated section.
All right, fairly complicated, but you know, as Mindset, we're here to simplify things, right?
Of course.
Right, Mindsetters, let me tell you that this show is proudly brought to you by Macmillan, and you can get your textbook, such as this one for geography. It is very helpful, and all the questions that we have today are from this textbook. Otherwise, chat with me on Facebook, like our page, or tell all your friends to join us on Facebook. Our page on Facebook is Learn Extra. Otherwise, follow us on Twitter at Learn Extra, and download your notes all for free on learn.mindset.co.za. For now, you're going to be telling us more about the lesson.
Yes.
What can we expect?
Well, we can expect a few things, really. We need to examine, firstly, the origin of mid-latitude cyclones. That's really important. We need to also look at the conditions that are necessary for their formation. We also need to look at the various stages that mid-latitude cyclones go through in their development. And lastly, and they like to always link these things to human activities, we need to discuss their effects on human activities, be it tourism, be it economic.
I'm so looking forward to that, but I must say to the Mindsetters, we do have a challenge question that is up already on our Facebook page, and Michelle is going to be telling us more about it.
All right, our challenge question for today. It reads, explain why mid-latitude cyclones only affect South Africa during the winter months. Now, I thought this would be a good question because it links back to your grade 11 syllabus. So in grade 11, you were learning about Earth's energy balance, and you were learning about global air circulation. So I need you to focus on those things also when you're trying to explain the answer to this question. More on that a little bit later. Let's get into the lesson. All right, we're going to start with a summary today. And the first thing that we're going to look at is their origin. So the origin of mid-latitude cyclones, first thing that you need to know is the latitudes in which they form. So generally between 40 and 60 degrees north and south, they form where we find the polar front. Now, you also need to know basically what the polar front is. And you need to also know that it's where warm, moist, subtropical air that's diverging out of the subtropical highs, that warm, moist air is meeting cold polar air. And that cold polar air is diverging out of the polar high. And so when they meet, they form an area which we call a front, separating two different air masses. So those conditions are absolutely imperative for those mid-latitude cyclones to form. Moving on, if we have a look at the development of them and their initial stages as we progress through to the degeneration stage. Stage 1, it's quite important that you know the names of each of the individual stages. So stage 1 is called the initial stage, the formative stage, in other words. All right, so first thing that needs to happen in order for a mid-latitude cyclone to come about is a wave in the polar front forms. Now, how does that wave form? It could be for a number of reasons. Sometimes there's a disturbance in our jet streams. It could be because of a mountain range or even a coastline. A jet stream, remember, we also did that last year, and you need to remember that it's an upper air level wind. It flows very fast from about 300 kilometers or so, and it moves from west to east. It's a permanent part of our circulation. So a wave needs to form first of all. We will show you some diagrams accompanying it to make it a little bit more sense to you. All right, a low pressure cell therefore develops. As that low pressure cell develops, you need to remember that air always flows into, it converges in a low pressure cell. So we say that the winds deflect due to Coriolis force as the air blows into the low pressure cell. Remember that term as well, a pressure gradient. That's quite important as well. It comes up a lot, even in tropical cyclones later on. Remember, pressure gradient, the definition for that is literally the change in air pressure from an area of high pressure towards an area of low pressure. And because of that pressure gradient, air will always move from a high pressure towards a low pressure. So air is converging into this low pressure because a pressure gradient has formed. So that's the first stage. Let's have a look at the second stage. Stage 2 onwards is quite a popular topic in exam papers, and they always ask something about the mature stage or even something about the occluded stage, which comes next. So stage 2, firstly, the name, always important, is the mature stage. It's reached maturity. All right, so what's happening now is we've had our wave form in the polar front. We need to remember that the wave deepens. Okay, the low pressure kind of becomes more intense. And because we have a greater change of pressure over a horizontal distance, we say our pressure gradient becomes stronger. All right. Once that happens, our polar front now forms two separate fronts. It forms the cold front as well as the warm front. Now you need to also remember the definition for a cold front and a warm front. A cold front literally translates to the leading edge of cold air. So it's ahead of the cold sector, the cold air, all right? Warm front translates to the leading edge of warm air. So we say it's ahead of the cold air, or ahead, in this case, of the warm air, right? So now we've got our cold front, we've got our warm front. Let's have a look at what else happens in this stage. This next point, where it says that air blows in a clockwise direction into the low pressure, you need to remember that the circulation for low pressure cells in the southern hemisphere is opposite to that of the northern hemisphere. So when we're talking about clockwise, remember that air blows clockwise into a low pressure cell in the southern hemisphere. If they ask you something about the northern hemisphere, characteristics of the low pressure are the same. The air is still converging, the air is still rising, but the air is now moving in an anti-clockwise direction. Very good to remember that. All right. With this cold front, now we start to experience various conditions. And with the cold front, we get thunderstorms. Okay? Thunderstorms come from big, built-up cumulonimbus clouds. With the warm front, we start to experience light, soft soaking rain. It's very widespread as well, and it comes from nimbostratus clouds, layered clouds which are fairly close to ground level. Right, stage 3 is what we're going to move to next. All right, stage 3 is called the occluded stage. And what's starting to happen now is because our air masses behave differently, we're going to start to see certain air masses being displaced. What do I mean by that? Cold, dense air will always sink. It's heavier, it's denser, so it sinks. It will wedge in, so it'll slide in underneath less dense, warmer air. This warmer air, therefore, we say is displaced. It's risen above the ground because of that cold air coming in underneath it. So warm air lifted off the ground. Our warm sector, okay, on a plan view that is, will appear to narrow. It doesn't mean that it's disappearing at all. It just means that the warm air has now been lifted almost fully off the ground. And in the occluded stage, as I'll show you in a diagram momentarily, means that at ground level, you'll only feel a little cold gust of wind, and all the warm air will have already risen off the ground. Right. In this stage, we get also nimbostratus clouds with a lot of rain as well. So that's the occluded stage. Let's have a look at stage 4. It's the degeneration stage, so it's kind of dying out. Okay? Only cold air is at ground level now. All of that warm air has lifted up into the upper atmosphere. We'll get a little bit of rain, but it'll start to clear. Even our clouds will start to clear up. The weather will be a bit brighter, a little bit sunnier. Our isobars will also look like they even out. There won't be such a steep pressure gradient anymore. So on the map, they'll look like they're more evenly spread apart. Those stages are quite important to know the characteristics of, not necessarily for an essay question or anything like that, but they will usually give you a diagram, and they'll ask you to identify the particular stage with which that diagram goes. Now that we've looked at the actual notes, I just want to show you a couple more diagrams so that you see what I'm actually talking about. All right. This first page here, I've tried to show you what the stages will look like in both the northern as well as the southern hemisphere. So in the northern hemisphere, there's stage 1, there's stage 2, and stage 3. Stage 1, notice here that it looks like the polar front is forming a wave. Same thing in the southern hemisphere. Remember, that wave is due to disturbances in a jet stream. Okay? You can see that air is blowing into the cell. In the southern hemisphere, note that it's going clockwise. In the northern hemisphere, we're still going to have air blowing into that low pressure cell, but it now blows anti-clockwise. You need to know those characteristics. I can't overemphasize how important that is. Stage 2, if you have a look here, we have a clearly defined warm front as well as a cold front. Northern hemisphere, the wind is still going anti-clockwise. If you have a look at the southern hemisphere, looks almost the same. There's our cold front over there. There's our warm front. And the air is blowing into that cell. This is where that pressure gradient is deepening a bit. When you get a synoptic chart to look at, and you will, trust me, they ask you to identify what stage this front is in. So where you see this stage, stage 2, when it looks like one of these, it means it's in the mature stage. Occasionally over South Africa, we'll get an occluded front as well. So if we have a look at both the northern and the southern hemisphere versions, the symbol for an occluded front, it looks like a mixture of the two fronts, warm front as well as a cold front there, and they seem to be merging together. You can see as well, look at this sector, this warm sector here, okay, there's the cold sector over there, but this warm sector looks like it's kind of narrowing, it looks like it's disappearing. That's not actually disappearing. You just need to remember that the air is just lifting off ground level. So on a plan view, you won't physically see that, but it'll look like that sector gets smaller and smaller. Right. If we have a look at a few other diagrams, it's useful to look at different diagrams, even Google them on the internet, because that's the way that you learn to interpret them a little bit better. Again, there's our 4 stages over here. There's the initial stage. Okay, a wave will form in that polar front. There's the mature stage. You can see at 2 and 3, right, there's the wave there. There's the cold front forming. There's the warm front. This is in the northern hemisphere because it's blowing anti-clockwise. And at part 4 here, there's the occlusion forming there, where that cold air is wedging in underneath that warm, lighter air. Right. Those are what they look like from a plan view perspective. Let's have a look and see what they look like from a cross-sectional perspective. All right, so don't get confused between a plan view and a cross-section. Plan view you'll usually see on a synoptic chart. A cross-section, they will give it to you as a diagram, or they might even ask you to draw out a section of that cross-section. And usually they focus on the cold front part. Let's just have a quick look at what we are shown in the cold front and the warm front. So I want you to notice here that your cold front, it looks like it rises at quite a steep gradient. Okay? It makes a very steep slope over here. Have a look at your warm front. It rises at a very gentle angle. All right, so what does that mean? Our cloud types will differ because of the fronts that they are forming along. Okay, so here's our warm air over here. That will be rising, remember. Here's our cold advancing air from the cold sector. It will sink and it will wedge in underneath the warm air. Along this cold front here, I want you to understand that the air rises very rapidly at a very steep gradient. And so what that means is that it'll form these big, puffy, tall cumulonimbus clouds. And when we have cumulonimbus clouds, they are often accompanied by hail, by thunder, and by lightning and heavy rain. Over a slightly more localized area, you'll find different thunderstorms affecting different places. If you have a look at the warm front, air is still rising here, but it rises at a very gentle gradient. So it forms a different type of cloud. The uplift is not so forced, it's not so rapid. We'll find that we form a few, or quite a lot of actually, nimbostratus clouds. And they're very widespread, and they'll give us very soft soaking rain. Okay, because of those different gradients which the warm front and the cold front form. Right, so when they ask you to draw a section of the mid-latitude cyclone, they'll most often look at this part, the cold front section. So you need to know how to draw that very well, please. And it's usually about 6 to 7 or even 8 marks at a time. Right. Let's have a look at another diagram. All right. Here we have a cross-section of an occlusion. All right. So we call it an occluded front. All right. So what's happening here? The cold, dense air has caught up to the warm air, and it's pushing that warm air above it. It's wedging in underneath it. All of that warm air, you can see here that it's now rising above ground level. When we get to the occluded stage, this type of cloud that's most often formed is nimbostratus cloud, and it will give us light, soft soaking rain as well. So on a cross section, you'll actually be able to see now that it's lifted completely off the ground. All right? And that now that cold air is kind of taken over. So at ground level here, okay, you'll see a lot of clouds, you'll feel a lot of rain, but it will start to feel quite cool. In the degeneration stage, all of that warm air has now lifted above the ground. All right? So when all of it is lifted above the ground, our pressure bars start to even out, and we'll only really feel a rather cool gust of air at ground level. Right, that concludes our summary. I hope that you have found that relatively helpful. When we do come back after the break, we will be looking at some questions that you hopefully will have had a look at as well, and we'll help you through those. Thank you.
Thank you so much, Michelle. On the page, the Mindsetters, they are giving us so many answers in the challenge question. I like that. And tell all your friends also to tune in and give us their own answers. Remember, you can answer the challenge question on the posted picture, not on the wall, but on the posted picture, so that later on we can give you the answer. Otherwise, during this break, test yourself. We have some notes with questions where you can test yourself. Take those. We'll see you after the break. Welcome back, Mindsetters. Now, if you just joined us now, you're a bit late, but you can still catch up. We are doing geography for grade 12s, so tune in and tell all your friends to also tune in your classmates, your group mates, and let's study together. But otherwise, don't forget that if you have some questions, feel free to ask them. Send them to our help desk at mindset.co.za or chat to me on Facebook. Give us those questions because we'd like to hear from you. Michelle?
Thank you very much. All right, now we've done the summary, we're going to look at a few choice questions, especially those pertaining to a synoptic weather map. Right, so you can be guaranteed in any exam that you do, you're going to get a synoptic weather map. They'll put features like mid-latitude cyclones, maybe tropical cyclones on. So there's a lot of information that you need to process. And you need to be able to identify quite a lot of different features. Right, but don't be scared off. It's actually really easy if you just put your mind to it. Right, so let's have a look. On this particular mind map, well, not mind map really, but synoptic chart, you will see it's a little bit different to what you usually see. You'll see that it's usually got black isobars and the rest of it is white, but we can work with this. All right, so first thing, just a couple of key concepts that you should know from grade 10 level. All right, an isobar, all right, like one of these lines here. They are lines that join places of equal air pressure. The isobaric interval, in other words, the difference between two isobars, all right, that is known as an isobaric interval, and that is usually 4 hectopascals. Sometimes, however, like in this example here, if they ever show a dotted line as an isobar, it means the interval is now changed to 2, all right, 2 hectopascals or 2 millibars. Okay, both are acceptable. All right, a couple of features I want to get into before we look at the questions. All right, we are dealing with winter scenario now. So this high pressure here, you should know the name of it. That is the South Indian high pressure. On the western side, we would usually have a high pressure here, and that would be called the South Atlantic high pressure. Remember that another word for high pressure is an anticyclone, so South Atlantic anticyclone or South Indian anticyclone. Those are fine as well. If we have a look at a couple of other features as well, this low pressure here, just remember that's called a coastal low pressure, which if you have progressed far enough in your syllabus, you should know about because it's coming up when we look at South African weather. More importantly, for mid-latitude cyclones, here's that plan view again. There's your cold front. There's your warm front. You'll notice that there's quite a few of them. Okay? There's another one over there. When we have a group of them, they tend to travel in groups or they tend to occur in succession, one after another. We refer to that as families of mid-latitude cyclones. So if you can remember these key little concepts, it's free marks in your exams. Okay, you'll notice that on this particular synoptic weather map, they haven't shown that many weather stations, but just to point out a few things, you'll see here where they show a triangle instead of a little circle for the cloud cover. It means that the station is automated, just in case they ask those things. We've got a couple of other weather stations over here. You'll notice that they've left out certain bits of information on those weather stations, like they haven't told you the dew point temperature. They haven't told you what other weather stations are around, but that's fine. We're going to work with that as well. So basically what you can see from this particular weather map is that we're going to be dealing with the mid-latitude cyclones. You're going to be also asked what sort of conditions they're going to bring across the country, especially the southwestern parts of the Cape. All right, so if we just have a look at that, examine it a little bit more closely. You'll see here, right, at this particular weather station, Eastern Cape area, you'll find that the cloud cover is not overcast just yet, but it's going to experience this mid-latitude cyclone, this cold front part coming across it in a day or two. So you're going to need to know what sort of conditions are associated with the cold fronts, especially for South Africa. They love to ask questions about the cold front weather pattern. Okay, so things like cloud cover will increase. Because the cloud cover is increasing, our pressure will decrease. Remember, we're having rising air, which is a low pressure, so that pressure will go down. Our humidity will initially increase as well. After the cold front passes over, after that's gone, then you'll find that the pressure increases again and the humidity decreases once more. Right, the temperature, because it's a cold front, we're going to see a temperature go down. We'll find as well, maybe there'll be a bit of thunder, a bit of lightning, a bit of rain. Okay, that's why in the winter months, the southwestern Cape, western Cape, they always get their rainy months in the winter. And other things that you need to look out for as well is what's going to happen to after the cold front pass, what's going to happen to things like the cloud cover. So initially we're going to have quite a lot of cloud cover, but then it'll start to slowly clear up as the cold sector moves on. Right, so those are quite important things that you need to know. Notice as well that these mid-latitude cyclones move from west to east. And the primary reason for that is they are driven by the westerly wind belt. Remember that the mid-latitude cyclones, they form in the subpolar low pressure belt as well. Right, now that we've analyzed the map a little bit more, let's have a look at our individual questions and we'll go through them quickly one by one. Right, so question 1 asked you firstly, what season is illustrated on the synoptic weather map? So how do we go about answering that question? Right, let's go back there quickly. Well, we can see that this cold front here is likely to push over southern Africa. And we know that mid-latitude cyclones, especially the cold front parts, they only affect us in our winter months. So the first clue there is that we have a cold front coming over us. Look at the air temperature as well here. It's only 22 degrees Celsius. That's a maximum temperature, right? Even on the coastal areas, that's a pretty cool temperature. So that time of the year would probably most likely be in the winter months. Right, so they're asking us for 2 reasons. So let's write them down. So we have a winter season. All right. Your reasons, you need to say that the mid-latitude cyclone, I'm just going to abbreviate, is affecting South Africa. And the air temps are quite cool. Right. Other things to look for, we'll probably do this in the next sections after tropical cyclones, but over the winter months, especially over Gauteng, over the interior of our country, we are dominated by high pressure. So that means we get dominantly clear skies. So you will see on the map that the skies are mostly clear, especially over our region during those months, over central South Africa. All right. Then question 2. They ask you to estimate the air pressure at the center of cell C. We go back to that synoptic weather map. I know the numbers aren't beautifully clear here, but I'll read them out for you. There's 1,020 hectopascals. That's 1,008 hectopascals. Remember that our isobaric interval goes up or down in 4 hectopascals. Okay? So if this is 1,008 hectopascals, it must mean, because we're going into a low pressure cell, that the pressure must be below 1,008 hectopascals. However, we can't just choose any number below 1,008. We have to remember that it has to be above 1,004 hectopascals, which would be the next isobar. So you have a few numbers to choose from, but make sure that it's not exactly 1,008 and that it's not exactly 1,004. It has to be somewhere in between. Let's write those down. So it could be 1,005 hectopascals. They also accept millibars. It could be 1,006 or 1,007. So any of those answers would be acceptable. However, if you put just 1,007 and then you forget to put the hectopascal, and I'm very strict with my children and I say that's wrong, okay, because what units are you using? So you must always remember to put those units with your answers to each question. We have a look at question 3. It asks you to describe the air movements associated with cell C. Usually it's going to be worth about 3 marks. Okay? And sometimes they even ask you to draw it in a diagram. So you must remember that we're dealing with a low pressure in the southern hemisphere. So you must also see that we have either converging or diverging air in high and low pressures. There is either going to be rising or it's going to be sinking, as well as the rotational movement. We're either going to have clockwise rotation or anti-clockwise rotation. All right, but because we're dealing with a low pressure, all right, the air is going to rise. It's going to converge at the surface. And because we're dealing with the southern hemisphere, and most people leave this one out, unfortunately, it's going to be moving in a clockwise direction. All right, and that will get you your 3 marks, easy as pie. Okay, let's have a look at question 4. It then asks you, from which pressure belt does cell C originate? Let's have a look at our diagram. Remember our mid-latitude cyclones, as I said to you earlier, okay? They form part of our subpolar low pressures. They like to give you a synoptic chart and say, what pressure belts are we looking at here? That comes from your global air circulation last year, so that knowledge really needs to filter in here. Let's write that answer down. You have to write it out in full. Subpolar low pressure. Very important that you write out the full name. If you just say low pressure, they're going to mark it wrong. We have equatorial low pressures and we have subpolar low pressures. So you need to be very specific about which pressure belt you are referring to. All right, usually that'll get you about 2 marks. Okay, also, easy marks. Let's have a look at question 5. Explain why mid-latitude cyclones move from the west to the east. Right? Also got to do with your global air circulation. Now you'll see here that they're going to affect South Africa. Remember I said that they're moving from the west towards the east. Okay, sometimes a little bit from the southwest towards the northeast, but overall you can just say the direction is from the west towards the east. Why? Because they are driven by a wind belt, and in this situation they are driven by the westerly winds. All right, you need to remember those things. Just before I write the answer down, however, I want you to notice that we have a succession of cold fronts and warm fronts and mid-latitude cyclones. Sometimes they're going to ask you which is the oldest one, or which is already affected South Africa, which is older. The one that's further east is always the older one. Why? Because it's traveled further with the westerlies. Just a key question to remember. Right, so the west to east motion is because of the westerly winds. You must say that they are driven or propagated along with the westerly winds. Let's have a look at question 6. Mid-latitude cyclones tend to occur in groups. What do we call these groups? Hopefully you've remembered what I've just said. They are called families. Okay, they move together, they move in families. Easy marks there as well. Also 2 marks at a time. Let's have a look at question 7. Alright, discuss. Okay, discuss means you have to mention an effect but also explain why it's happening. Okay, it's very important that you remember to do that. Explain how weather conditions are going to change over the Eastern and Western Cape regions over the next 2 days. Don't just read that part and be like, oh, I know about 6 different things, and start jotting them down. Make sure you finish reading your questions because they only ask you for a select few things. Refer only to precipitation, humidity, and that should have been pressure, so let's just change that one there. Okay. Right, so we know from looking at that synoptic chart that the cold front is usually the one that's going to affect those southwestern Cape regions and the eastern Cape regions. So you need to know what's going to happen most often with the cold front. Okay, so let's have a look at each of them. We need to say that the precipitation, so let's call that number 1. We might see rain, okay, might be quite heavy rain, and thunderstorms. All right. That'll get you your 2 marks there. Let's call humidity point number 2. Remember, as I was explaining earlier, I said as we approach that cold front section, our humidity levels increase. Why? We've got moist air, warm air that's rising because of that cold air wedging in underneath it. So that means our humidity levels are going to increase as that air rises. So humidity will increase. Let's call our pressure number 3. Humidity and pressure go hand in hand. When our humidity increases, our pressure decreases. When our humidity decreases, our pressure increases. So that's just an easy way to remember those two. So our pressure, because we've got rising air as that cold sector approaches, our pressure is going to decrease. All right. If you have a look at why it's happening, you also need to, with your answers, you can't just write what I'm doing there, but you need to explain it. So just remember that the rain and the thunderstorms are because those cumulonimbus clouds are forming, because rapid air is lifting above that cold sector. Humidity levels are increasing because as air rises, it absorbs water, it evaporates water. It's going to create condensation and clouds. Our pressure will decrease as well because our air is rising, creating a low pressure there. Let's quickly see how many more we can do. In what stage is cell C? And explain your answer. So we're looking for the stage of cell C and an explanation there. All right, let's go back to the top. All right, if we have a look at cell C, you can see a cold front as well as a warm front. So there they are again. you can't really see an occlusion happening yet. So when there's no occlusion, there's no joining of those two fronts together, we must know it's in the mature stage. Okay, because there's no occlusion. Let's write that down. Okay, so mature. Right, there's no occlusion present. Right, quickly. Explain how the wind direction at Marion Island is going to change over the next 2 days. So if we have a quick look again at Marion Island, that's quite south, quite a lot south of South Africa. There it is there. The wind direction in this case is going to be, say, north or northwest even, maybe. Yeah, they'll accept either of those. So if the wind direction is north-northwest, you need to understand that as this cold front passes over, it means that we call the wind direction, we say that it's backing. Okay? And in the southern hemisphere, we say the wind direction backs, it changes in an anti-clockwise direction. In the northern hemisphere, it does the reverse. It's going to veer, we say. So it changes direction in a clockwise fashion. Right, let's have a look. Almost there. So it's already at north. So if it's backing, it's going to change anti-clockwise. So it's going to become a northwesterly wind and then a westerly wind as that cold front sector passes over. Okay, last question. It says describe 2 negative effects that mid-latitude cyclones could have on the economy of the Western Cape. So how does the weather affect the economy? Well, it does in a big way. No one wants to go down to the Western Cape in July for a holiday. Let me tell you why. Because it's raining all the time. So no one's going to want to get a suntan. They're not going to want to go to the beach. So because of that cold, wet, rainy weather, it means less tourists go. So the tourism economy declines. Second thing as well, when we get a lot of rain occurring in a short space of time, which may happen there, it means crops could fail as well. Maybe even infrastructure can get damaged. And in these ways, our economy could decline significantly. Let me write those down very quickly. If I could get back to that. There we go. Don't have space here. I'm just going to put some keywords there. Tourism will go down because no one wants to visit there at that time of the year. It's not pleasant weather. Okay? And we could have crop failure as well, which means we have less crop to sell to boost our economy. Thank you very much. That concludes the questions.
Thank you, Michelle. On the page, I see the mindsetters are also giving us their answers. Keep them coming. Remember, also, you can ask your own questions. This is your chance. If you don't understand anything that Michelle is going over, let us know because we're here to help you. Otherwise, we'll see you after the break. Welcome back, mindsetters. Now, the moment that we've all been waiting for, just to hear the answer for the challenge question. I've seen lots of interesting answers. Trust me, Michelle. Like
I'm sure you
some,
have.
I just can't wait to find out the right answer. I'm sure the mindsetters also want to find out the right answer. But in the meantime, if you still have some questions, feel free to throw them on the Facebook page, which is Learn Extra. Like the page also and share it with your friends. Michelle?
Thank you very much. Right, so let's just go through that challenge question again. I asked you to explain why mid-latitude cyclones only affect South Africa during winter months. And I said that links quite a lot back to your grade 11 syllabus. So let me explain it to you quickly now. When we looked at the energy balance or the uneven distribution of solar energy on the Earth's surface, that first chapter, and we looked at global air circulation, we examined how the seasons changed during the year as the Earth revolves around the sun. And because of the Earth's tilt and a range of other factors like axial parallelism, like the sphericity and the tilt of 23.5 degrees, as well as the rotation of the Earth itself, meant that at certain times of the year, the southern hemisphere is facing towards the sun, and that at the other time of the year, on the other side of the revolution around the sun, the northern hemisphere is facing towards the sun. So that means at those times of the year, the southern or the northern hemisphere will be receiving more direct, intense insolation. So if we go back to our global air circulation, we already know that where we have the most direct insolation is where we have our equatorial low pressures. Right? So if we have varying amounts of insolation in the northern and the southern hemisphere, it suggests that our equatorial low pressures, our ITCZ, will appear to shift northwards or southwards depending on which hemisphere is having its summer season. Now you need to remember that our ITCZ, or our equatorial low pressures, they don't just move in isolation. Okay? When they shift north or south, the subtropical highs, the subpolar lows as well, they will shift north or south. So that means in our winter season, the ITCZ, the equatorial low pressures, are now north of the equator, somewhere near the Tropic of Cancer. So that means all of our subtropical high pressures have shifted north, as well as the subpolar low pressures. If they have shifted north, it means that they are close enough to South Africa for mid-latitude cyclones that are forming to affect those regions over South Africa. So that could be worth quite a few marks. You need to explain the change in season. You need to explain the shifting of the pressure belts, as well as the fact that the subpolar low pressures at those times of the year, so in our July, in our June time, they will be closer to South Africa so that they can affect our country. That's the answer.
Wow, thank you so much. My teachers, the answer is posted on our Facebook page, so check it out on the post where we had the challenge question. Big ups to everybody that got it right. But now I think we should take some questions from the mindsetters.
I'm happy to have those questions.
Right. Before we take those questions, I have some shout outs from the mindsetters that are watching, and they've been screaming, saying, please highlight us. We have Lungsta Busan who's saying, I'm enjoying the show. Highlight you, mindsetter. We have Jekiminis who's watching, highlight you, mindsetter. Awesome. Let's take some questions and we'll highlight other mindsetters later. Nokwanda says, how does mid-latitude being formed? And I'm also struggling with the stages.
Okay, so remember, it's a good question and you need to get it right, that the initial stage in the formation of a mid-latitude cyclone is the wave that forms in the polar front. Now we've got a question about polar front coming up next, so I think I might as well answer that one as well. A polar front, okay, a front is basically a zone where two different air masses, both of different densities and temperatures, meet. Okay? So what's happening, and you'll need to consult your grade 11 global air circulation model in order to answer this nicely. Air that diverges along the surface of the Earth out of the subtropical high pressure at 30 degrees, it will move towards the poles. At the same time, cold polar air from 90 degrees north and south also diverges at the surface and moves towards the equator. So at some point, those two air masses meet. So where we have warm subtropical air mass meeting the cold polar air mass, we have a front. And the reason that front forms is because those air masses can't mix. So the warmer air will rise, it'll be forced to rise, the colder air will wedge in underneath it. And as that air rises, it gives rise to low pressures, as well as the fact that it leads to condensation because of that warm, moist, rising air. I hope that helped in terms of the polar front. With the stages, as that polar front wave forms, remember, it's formed because of a disturbance in the jet streams, or because of a mountain range, or because of a coastline. A wave forms, literally a wave forms, okay? And when we have a wave forming, we start to have deflection of winds going into a lower pressure, right? That's the initial stage, that wave forming, okay? A small wave. As that wave deepens, we get to, or becomes more exaggerated. we get more to the mature stage. And that polar front that's just formed a wave now will form a cold front and a warm front. All that means is that it's just separating the cold sector from the warm sector. Remember, cold front, the leading edge of all the cold air behind it, the warm front, or the cold or the warm air, behind it, it's the leading edge of all that warm air. Right, so it's basically designating where the warm sector is and where the cold sector is. As that front travels, or both of those fronts travel with the westerlies, okay, the cold air is denser and it's heavier, so it sinks. And as it does so, it's going to force all the warm air up. So on the diagrams that I showed you, it appears almost as if the fronts are catching up to the cold fronts catching up to the warm fronts. Okay? Looks like they merge together. It just means that the warmer air at ground level is being pushed up above the cold air, which is wedging in underneath it. Okay, so it's just a removal of that warm air upwards. It's displacing it upwards. Then we say it's occluded. And once all that warm air has been lifted off above the ground, at ground level you'll just feel cold, gusty conditions. And eventually the low pressure will disappear as all that cold air has sunk to ground level. I hope that helps paraphrase a few of those stages, but I do suggest that you go back and you read through them carefully.
All right,
next one.
I think you've also answered another question from Wiseman, which was also about the polar front.
Okay, yes.
Yeah. Let's move on to another question.
Of course.
Right. Sophie says, to see whether the pressure is below or above 1,000 hectopascals, do we have to look to the whole isobars or on the map or in the middle one?
Okay. So remember that your low pressure, or the isobar around the low pressure, not in isolation of others. So you need to look at it holistically. So the L on your map for the low pressure shows the center of that pressure cell. So that means all the pressure, all those isobar lines, as you move towards the low pressure, they decrease. So you have to look and see what the isobar readings are showing you. And where the L on your map is, the isobar around it will tell you what the pressure is, so 1,008 hectopascals. But you must remember at the center of that cell, the pressure is still even lower. So you have to choose a number that's still below that 1,008, but above the next would-be isobar, which would have been 1,004. Okay, so it's like reading contours on a topographic map. It's the same concept. Okay, so you just need to choose a number that's below that nearest isobar. If it's a high pressure, you're going to do the reverse. So you'll see an H with an isobar around it, and you need to estimate a number that's slightly greater, maybe one greater than the reading on that isobar next to the H in the middle of the cell. So if you're still struggling with it, it's the same idea as reading altitude off a topographic map. You're estimating values based on ISO lines. Okay, I hope that helps. Next one.
Next one. What is the other name of mid-latitude cyclone?
It's called a temperate cyclone. So in an exam they might use temperate, but most of the time they use mid-latitude cyclone.
Okay, the last one. What is the impact of flooding in the economy and the environment?
Okay, the impact of flooding on the economy and the environment. This section permeates through both mid-latitude cyclones as well as tropical cyclones. Okay, more intense with tropical cyclones. So when we have flooding, things like our crops, they will get washed out, okay, they will be destroyed. In addition to that, all the valuable topsoil that we use to farm, that will also get washed away via erosion. So we're losing all that good topsoil, that fertile topsoil, and we're losing the crops, which means we can't replant them. So in terms of the environment, there's soil erosion, okay, which could damage ecosystems even around it. And the economy linked to this is when we damage our crops, we can't supply food to industry, we can't supply food to retailers. So all of those link industries, they will also start to suffer for that lack of produce. Even things like hail, they damage crops, okay, so they could also lead to a loss of income, especially for those farmers. Now remember, farmers, they often have loans for insurance, so they'll have lots of insurance claims as well because of their lost crops. I
Thank you
hope that
so
helps.
much, Michelle.
And your pleasure.
Unfortunately, we just have to end it there for today.
Okay.
I hope you enjoyed yourself as
I
much as the
really
mindsetters
did.
have.
Thank you so much for having me.
Right. Thank you so much, mindsetters, for tuning in, and thank you so much to Macmillan for proudly sponsoring this show. Get your textbook right now. Otherwise, from us to you, we just want to say keep your questions coming because we'd like to learn more and learn extra with you. Peace.